This is the Vika Academy, and today we are looking at boundedness of sequence. Remember, this is a topic in relation to real analysis, which cuts all across pure mathematics. So it's very important you note this. And if you have not subscribed to this channel, kindly subscribe, and also share with your friends. So a sequence xn is said to be bounded above if there exists a real number a such that the sequence is less or equal to a. That means it is bounded up above. There is a a above the sequence. Again, we say that the sequence xn is bounded below if there exists a real number b such that that sequence is greater or equal to that b. Remember, this is for n in n. So we say that a sequence is bounded if there exists a given m, which is a real number, such that xn absolutely is less than that m, is less or equal to that m. What does this mean? It will mean that it lies between the negative sign of m and the positive sign of that m. So the sequence is in between. If the sequence is in between those, then we say that that particular sequence is bounded, because it's bounded half above and also bounded below. So some bounded below. Let's look at this example. So we have this xn here, which is a sequence whereby we get 1 if n is odd, and we get 0 if n is even. That means xn will be bounded. Since the range will be 0, 1, it will be 0, 1. It will be 0, 1. So it lies 0, 1, 0, 1. So the sequence xn equal to n squared. For n in n, you'll find this one is not bounded because we can't get the half above and the below. So in this case here, the sequence xn, another example given like this, for n in n, you'll find this one is bounded because it have infimum, which is the greater lower bound of 2. You can see we'll have 2 when n is equal to 1. That's 2, and the supremum of 3. You can see the supremum will be 3, the lowest upper bound. Okay, a real number b. Let's look at another point, which is called limit point of a sequence. Remember, previously we looked at limit points generally. Now I want to look at limit point of a sequence. So a little number b is called a limit point of a sequence xn if every neighborhood of b contains infinite number of terms in the sequence. So if it happens that the neighborhood of this b, which is a limit point of the sequence, the b which is the neighborhood, the b which is a point in the sequence, if it happens that b is having infinite many terms in the sequence, then you'll find that this b now qualifies to be a limit point of a sequence xn. So first thing, you have to look at the neighborhood of that particular point b, and if it happens that it contains infinite many terms of sequence, terms of the sequence xn, then you say that b, then it must be a limit point of that sequence. So B, remember, is a member of real set. Remember, in this topic here, or in this unit about real analysis, our interest is real numbers. So that's the reason every time we are quoting a point, we say it's a member of real set. So B being a member of real set, we say it's a limit point of xn if given n positive epsilon, however small, xn will be inside that opening bracket. You want that B, because this is actually the definition of neighborhood. The neighborhood of B is you take B to subtract a given small epsilon, and then you get B and you want a small epsilon. So that is actually the neighborhood of that B. So the B, if you have B here, its neighborhood is B plus epsilon, and again its neighborhood here is B minus epsilon. So if it happens that this this neighborhood here of B, you'll find that it is inside that sequence is inside that, then it implies that it has infinitely many terms of the sequence. It's in the neighborhood, it has infinite many terms of the sequence, and therefore you'll find that B is now the limit point of the sequence. This is for n infinite number of values of n, and this implies this, and again it implies this. That is definitely true. That's definitely true. Okay, if you look at some examples here, we have that sequence here. You can see this one has a 0. If you take 0, it has a 0, which is a limit point. And again is also a limit point of the range of the sequence. So you look at the main part of the sequence when the 0 is again, and then if you look again at this one, fine. So the neighborhood of 0 in this sequence is having many terms of xn, and that the reason we are saying 0 qualifies to be a limit point of this sequence. If you look at this again, this sequence here, you'll find that this one, it gives you that we have 1, because the upper part and the lower part -1, and they are actually the limit point, because you find that this is the neighborhoods of 1 and -1. They are having infinitely many points of xn, that sequence. So that is in domain. That's in domain. Domain is correct. But if you look at the range, you find that this one will have no limit point because it is recurring. It is recurring. You have -1, 1, -1, 1. So that range means that it doesn't have any point that you can call a limit point. Remember, if you have not subscribed to this channel, kindly subscribe, so that every time I post anything about algebra analysis, you are the first one to see it, and again to get educated and get knowledge on that. Again, share with your friends so that every time again they will be also able to see the content. For now, that is it.